builder notation. And so that's where we're going to pick up with today. And so we already went through what set builder notation looks like. And so what I'm going to do now is I'm going to go ahead and describe that using set builder notation. Okay, and so in looking at this, what I'm going to go ahead and do is I'm going to go ahead and start with the very first thing that starts with set builder notation. That's that little squiggle line. And then what came next, if you remember, was an X. And then what came next is that vertical line, which means such that. And so then now the question is, we have to now write an expression that encompasses the numbers 2 through 7. So a good way to do this is to use kind of the expression that they had up here. All right, and so I'm going to start with 2. What will come next?
Greater than, not greater
What's
than.
that symbol?
Less than.
Less than. Remember, less than always points to the left. So that's the easy way to remember it. Okay,
X.
what will come next? X, yep. And then?
Okay, then 7.
7. So now I need to think about, okay, what types of numbers are between the 2 and the 7 here? If you notice, all of them are whole numbers. They're also integers. They're also natural numbers. So I could have any of those. I could have a whole, natural, or integer. I'm just going to go ahead and use an natural number just because that's the most basic one. But understand, I would also let you have a whole and an integer there. So that is what set builder notation is.
So the first and the last numbers in the set are going to be the ones on the left-hand side of that. And then you just have to decide whether it's integer or
Yep.
natural.
Let's go ahead and look at another one. Okay? Describe x is greater than negative 17 using set builder notation. So now this is a little different than the previous one, but you can still do this. So where do I start?
X line.
Close. Let's
Squiggle.
reference the squiggle. Yep, and then you're right. Then I do the x in the line. And then what?
X is greater than or equal
Greater than negative 17. So now I need to think, what types of numbers am I dealing with? So when I look at this inequality, x is greater than negative 17, what ends up happening is I like to think of things along a number line. And so here's negative 17 down here. If I were to graph that on the number line, what would it look like? Yep, an open circle at negative 17, and then what? Shade this way. So basically it means every number, everything bigger than negative 17. What symbolizes every number? What symbolizes
to
every?
count numbers, real numbers.
Ah, what'd you say? Nope.
Real numbers.
Real numbers. Because remember, the real numbers are every possible number. The irrationals, the rationals. So that would be the real number. So when you want every possible number, you're going to use the real numbers.
So then when there's a, like a, I don't know what to call X is greater than -17. So when there's not a set of numbers, that thing just goes in there without doing like the equal or greater than or equal to, greater than or equal to.
Okay, let's look at this one. Describe all multiples of 7 using set builder notation. Describe all multiples of 7 using set builder notation. Now this is a little different. So how do I start? X. Yep, line.
Squiggle.
You gotta start with that first. Now I need to think about multiples of 7. What are the multiples of 7? 7, 14, 21, 28. Okay, so basically I'm taking 7 times all these different numbers, right? So how I can symbolize that, and this will be something you need to file away. If I want the multiples of something, I'm going to take whatever that something is times n. So if you wanted the multiples of 5, it would be 5n. If you wanted the multiples of 4, it would be 4n. Now this is the thing. I've got to tell you what n is. And I'm going to tell you right now, n is an integer. N can be negative. So think about it. I could put like -2 in there and get -14, and that is a multiple of 7. So this is how you do the multiples. But I've neglected to say what x is an element of. So let's think about that. If x is all the multiples of 7, okay, so we're dealing with like -21, -14, -7, 0, 7, 14, 21. What types of numbers are those? Integers, okay? Because when you think about it, they're the negatives too, and the positives, so those would be integers as well. So if you have one on your homework that deals with multiples, you're going to want to look at that in your notes. Okay, so if you have one in your homework, go back to this one and look in your notes. Pretty much everything will be identical except for the 7. Okay, let's look at another one. Describe that using set builder notation. So you got your expressions handy. So I need you to go ahead and enter that in. Describe that using set builder notation. A, B, C, or D. So let's see what we got. Oh. Interesting. Who had C? That's right. C is the correct answer here. Why is C the correct answer as opposed to D? There's 3 little things that you missed. Dot, dot, dot. Dot, dot, dot means you keep going. So we're referring to 11, 12, 13, 14, 15, and it keeps going on forever and ever. So that's why we're dealing with x is greater than or equal to 6. Now why it is not greater than is that, it is not just greater than, is because 6 is included. Okay, so x is greater than or equal to 6, and x is an element of the natural numbers.
So does that mean that A and B are the same thing?
Technically not, because A would be like 7, 6, 5, 4, 3. So A is going down where B is going up. Okay, so let's go ahead and look at the next thing we're going to talk about, and that's interval notation. And you're kind of getting cut off. You can follow along in your book. You don't need to necessarily probably write down too much on notes on this. You're going to like this. It's short, it's sweet, and to the point. Interval notation is another way, other than set builder notation, to write intervals. Okay, the nice thing about interval notation is that you don't have to worry about a prescribed form or prescribed expression you're going to use. Okay, basically with an interval notation is we're saying, okay, what's the interval of numbers we're using here? Biggest thing you need to get here on interval notation is that if a number is included, you use brackets. If a number is not included, you use parentheses. If a number is included, you use brackets. If a number is not included, you use parentheses. Okay, so I'm going to go ahead and look at this right here. It says write -2 is less than or equal to x is less than or equal to 12. So now I need to think, if I was going to graph that on the number line, okay, if I was going to graph that on the number line, it's going to look something like, here's 0, we'll go by to 2s, 4, 6, 8, 10, 12. What's going to happen? What am I going to have? Oh, -2, sorry. Let's undo. Sorry, I guess I need to put a -2 here. We'll go -2 here. Okay? negative 2 and 12, and then what am I going to do?
Shading.
Shade in between. So now interval notation wants you to give the endpoints. What are the two endpoints here? Negative 2 and 12, and I'm going to separate those with a comma. The next thing I need to figure out, do I include negative 2? Is negative 2 included on the graph? Yeah. Is 12 included on the graph? Yeah. And what tells us they're included is this equal to sign. So whenever you see that equal to sign, you don't necessarily have to graph. I was just doing that so you could get a visual of what it looked like. Okay? And that is your answer. That's all you do. So let's look at another one of those and see. Write x is greater than negative 4 using interval notation. So once again, I'm just going to draw you a quick sketch because I think it'll be easier to understand. So here's 0. Let's go with negative 4 right here. What would that look like if I was going to graph that? Open circle.
Shade to the right.
Shade to the, oh, you're right, shade to the right. Sorry, because it's greater than. So now I need to figure out what the boundaries are. So what is my leftmost boundary in that graph? Negative 4. Is negative 4 included? Is it shaded in? No, so I'm going to use a parenthesis. Okay. What's the rightmost boundary? The rightmost boundary is the arrow, right? It keeps going on forever and ever. So how we signify the rightmost boundary here is we use infinity. Okay. The rightmost is going to be infinity. What would the leftmost be, just for kicks? What would the leftmost boundary be? Negative infinity. Okay, now the thing about infinity is it's not a number. So since it's not a number, whenever you use infinity, it will always have a parenthesis. So whenever you write down infinity, you never have to think, oh, is it a parenthesis or a bracket? It's always a parenthesis. And there you go. All right, let's look at another one. Write this using interval notation. So we're going to split up, divide, and conquer. I want this half of the room here. You're going to do the first part. You are going to do the x is less than 3. This half over here, I want you to do the x is greater than or equal to 54. Okay, so when you get it done, I need somebody to tell me what it is, and then we'll talk about how you do that in your final answer. So do we have anybody that has one? Yeah. What do you got? Yeah. Yeah. What do I put here? Remember with infinity, I use parentheses. But yeah, you're right. You got the 54. But with infinity, we always put a parenthesis with that infinity one. We can do both. Do you guys have that other one?
Yeah.
Yep. What is it?
The parentheses.
Yep.
Negative infinity.
Yep.
3.
Yeah.
parentheses.
Okay, good. Now, what we have is we have this or this. And so you can put the word or, but mathematicians kind of have symbols that we use to symbolize or and and. And so the symbol we have for or is it's what is known as the U. It's a union. Okay, when we refer to or, that means the union of two events. And so we would use that U. So either of these would be acceptable. I'm just showing you it both so that if you get to like your homework and you're like, what does that U mean? All that U means is or. Those two are the same thing. Yeah? Yep. No. You always start with your leftmost point.
5 Why is there a bracket
Okay.
on one side and
Because 54 is included. That's what this equal to sign means. Okay? So whenever you have that equal to sign, that means 54 is included. And infinity always has a parenthesis. So with that in mind, here's your chance. Okay? Write that using interval notation. Same thing. Okay. Using interval notation, write that. Okay, I'm going to give you about 30 more seconds and then I'm going to... Okay, so let's see what we had. Oh, nice. A is the answer. Good job. Okay, so let's go ahead and look at that. The difference between A and B are brackets. So if I look at this, is there an equal to sign here with the 5? No. So that means 5 is not included. That means it goes up until 5. So that's why we use the parenthesis here. No equal to sign here either with the -1. So -1 is not included. Okay, so that's why we use parentheses there. So, okay, let's look at the next slide. We're going to talk about functions now. We discussed this last year. So once again, we're not going to spend an incredible amount of time. We're going to go fairly fast through this. Remember, a function is a relation that assigns to each element in x exactly one element in y. So each x has exactly one y. That's what you got to remember. Each x has exactly one y. The other thing you need to remember is that the function passes the vertical line test, which means if you take your pencil and you move it across a graph, it will never touch more than one point. So what I tell a lot of the kids, let's imagine a graph. Okay? So let's look at this next one. It says, determine whether the relation represents y as a function of x. So the input value, x, is the height of a student. So if I think about a graph, x is going to be the height of a student. And it says y is the number of books the student owns. So here's the number of books a student owns. So let's imagine we're talking about somebody who's, I don't know, what do you think, 5'5"? 5'5", we got a lot of people that are 5'5". Okay. So, aren't you 5'5"? Okay, anybody else 5'5"? Probably not your tall. I'm 5'5", so we'll go with me. Okay, how many books do you got at home? Huh? Quite a few, so what? Let's approximate what? 20? Okay, we'll just say 20. So here you would be plotted on the graph, right? Now me, got a ton of books. That's what happens when you have a little kid. Okay, a ton of books. You read to them. So let's just say I had 100. Even though it's probably more than that. Is that going to be a function? No, because it doesn't pass the vertical line test. See how that kind of works to visualize? So if you get stuck, draw something out like this and think about it that way. Okay, so this would not be a function. Let's look at this one. Okay, this is a table. Remember what I said. Each x has exactly one y. So here's an x, right? 1 and 1. Does that have exactly one y? No. So is this a function? No. And once again, if that really confused you, let's plot it. Okay? Here's 1 for x, and it says the y is -1, and positive 1. So you can see that way it fails the vertical line test. Let's look at this one. Is that a function, yes or no?
Yes.
Yes. One thing I want you to observe, y equals x squared. Okay? This was a parabola. We learned about parabolas last year. But x squared is a function. Oh. Let's go to this one. Determine whether x equals y squared is a function. Oh, so we don't have a picture.
No?
What?
No.
Let's think about things. Okay, so I see the number 3's in there. So I'm just going to say, okay, let's start with x. I'm just going to let x equal 3. Why? Because it's a multiple of 3, and I already see there's a 3 in the problem. I could let x be 6, 9, 12, something like that. I'm just going to let it be 3. So if I let x equal 3, I want to solve that for y. Now, why am I doing this? Because I'm going to see if there's 2 y's that go with that x, right? And you know it can't happen. So let's go ahead and, what do I do here? Divide by 3. So what do I get? Y squared. Okay. What do I do now? Huh? Square root. What's the important thing about a square root? What's the square root of 1? 1. So look at what I got for y. How many values did I get for y? 2. With 1 x. Can you have that? So this is not a function. So let's look back. What did this have? This had a y squared, right? What happened with the x squared? Was it a function? Yes. With the y squared, was it a function? File that away to memory. Okay. File that away to memory. Because actually, what this is a graph that looks like, this is actually a sideways parabola that goes this way. So that's why it fails the vertical line test. Remember, the other one was an up and down one, so it passed it. When it's a y squared, it's actually a sideways one, so that's how come it fails it. Like I said, file that away to memory. So with that in mind, look at that one. Yes. Okay. See? See how those little tricks kind of help? So anyway, that one will be because that's going to be a parabola. This one actually is going to open up and down, or it's going to open down though. All right. Real quick, I want you to type in what you think the solution is right there. What the solution is right there. You can do that one. Okay. Not an overly difficult problem. You should be able to handle it. Okay? All right. Okay, let's see what you get. Answer is -5. Nice job.
How?
Okay, this is not a hard problem. It says find f of 3. All you're going to do is plug in 3 for x.
Oh,
That was a pain.
3 squared
see that?
minus 2 times 3 minus 8.
Yeah.
Okay.
So you end up getting 9 minus 6 minus 8, which is -5.
Yeah,
Okay?
That's, I did.
All right, let's look at this one. Find f of -3d. Now this one here, if you notice, okay, it's the exact same problem as it was before. Okay, the only difference now is that we're finding f of negative 3d. So I'm going to do negative 3d quantity squared minus 2 times negative 3d minus 8. Remember, I square each of these. What do I get here?
Negative 9.
What do I get here?
9d squared
9d squared, yep.
minus plus 6d.
There you go. Okay, because a negative 2 times a negative 3 is a positive 6. Okay. So now we've dealt with a number and a variable. Now we get to a quantity. Once again, it's the same problem as the one before. We're now just doing 2a minus 1. So this one, what I'm going to do is I'm going to take 2a minus 1 quantity squared minus 2 times 2a minus 1 minus 8. Now, what a lot of people think is that you square the 2a and you square the 1. That's wrong. Okay, can't do that. What you need to do,
Is you do that.
2a minus 1 times 2a minus 1. And you have to FOIL that. So let's start. What's first times first?
4a squared.
4a squared. Now, you're in pre-calculus, so I expect you to do the next two steps in one. Okay, so outer and inner. What does that give you?
Plus and
Minus, what'd you say? 4a, yep, minus 4a, because you get negative 2a, which is negative 4a. What's your last term?
plus 2.
Plus 1. Okay, let's distribute the negative 2. What do you get when you distribute the negative 2?
Plus 2.
2. Then I'm going to bring down the minus 8. Next step is to go ahead and simplify. So I get 4a squared.
Minus 8a
Yep.
plus 11. Oh, wait, no, that is different. Right, negative minus 5.
There you go. So quantities. All right, now what we're going to do is we're going to do some domain problems, and this is where we're going to end. Now I need you to stay with me on this one. I know you're tired, it's the end of the day, but, okay, this is some pretty intense stuff. So, to find the domain of a square root, you're going to set the square root equal to 0 and solve for the variable. To find the domain of a fraction, now when I say of a fraction, I don't mean any fraction, I mean the fractions we're looking at today. Okay, set the denominator equal to 0 and solve for the variable. Okay. So those are the two things we're going to look at. What happens when we have a square root? How do I find the domain? And what happens when I have a fraction? How do I find the domain? Alrighty. So let's go ahead and look at an example. Like I said, try and stay with me. Now, one of the things is you can probably cut off some of that. You don't have to write every word verbatim. Okay, so state the domain of the function. F of x, or g of x equals 4x minus 1. So we're finding the domain. So if I was taking notes, this is what I put, domain and then write the function. Okay, it's one of those things you need to kind of abbreviate what you all write down. It's not necessarily going to be everything that's on the board. So I would do domain g of x equals 4x minus square root of 4x minus 1. Now if you remember, what did it say about the square root? What do? Set the square root equal to 0. So I'm going to take 4x minus 1. I'm going to set that equal to 0 and I'm going to solve. What does x equal? 1/4. Okay. Now with the square root, okay, I need to think about, okay, the domain. All right, so I'm thinking about 1/4, and when I think about the numbers around 1/4, let's think about that. What would be a number smaller than 1/4? Number smaller than 1/4. 0. Okay, we like 0. 0 is easy to plug in. If I plug 0 in here, what do I get? -1, right? -1. Can you take the square root of a negative number? No. So 0 doesn't work. So, okay, so that means numbers less than 1/4 don't work. What's a number bigger than 1/4? 1. So let's plug in 1. What do you get?
2.
What do you get when you plug 1 in?
No.
You get what? 3. Can you take the square root of 3? Yeah. So numbers bigger than 1/4 work. So let's write that in interval notation. What would that be in interval notation? Let's think about that. Interval notation. Numbers smaller didn't work, numbers bigger worked. Yep. Infinity, good. Now, what goes with infinity? Always. Parentheses. What goes here? Bracket, right. The reason a bracket goes there is because you can take the square root of 0. When you plug 1/4 in here, you get 0. You can take the square root of it. So that's the domain. Let's look at this one. This one's a fraction. Okay. Okay, so h of t equals 3t squared over t squared minus 1. First thing you're going to do, you're going to set the denominator equal to 0. Okay. So t squared equals 1. What does t equal? T equals plus or minus 1, because whenever you take the square, you have to take both the positive and the negative. All right, so now I need to think about that. So if I think about the numbers positive and negative 1, let's just think about, I don't know, -2. If I plug -2 in here, do I get a value? If you plug -2, what do you get? 3. Works, okay? If you plug 0 in, what do you get? -1 works, right? So basically, if I think about that, I could plug every number in, but there's a number I can't plug in. When I have a fraction, what can't I have in the denominator? 0. What makes this 0? What two values? The same ones you found right here. Okay. So when you have a fraction, you're going to have all reals except for those numbers right there. We've got about 2 or 3 more we're going to look at. All right, this next one, this is a little different. Okay, a little different on this next one. Now this one has both a square root and a denominator, so where do you start? We're going to start with the square root, okay? Well, the denominator, I mean exactly what you said. So when I have the square root, I set this number equal to 0. So I've got 2x minus 3 equals 0. What does x equal? 3 halves. So if you remember, what I did with the square root is I went ahead and figured out an interval that worked. So what would be a number smaller than 3 halves? 0. Let's plug 0 in. You always want to plug 0 in. It's nice. If I plug 0 in here, what do you get? -3. Can you do negatives? No. So I can only do numbers bigger than 3 halves. So I've got 3 halves, and numbers bigger than that will be what? Well, how do I write it?
4/2?
How do I write it in interval notation? Infinity, yep. Okay, infinity uses a parentheses. This uses a bracket. But let's think about that before you write that in. Okay, I'm in the denominator. What can't you have in the denominator? 0. What value of x makes this 0?
Infinity.
What value of x makes that 0?
3, 2,
Why does that make it 0?
3 halves. Okay, so we can't have 3 halves. So what do I need to do to adjust this?
Wait, why does that make it 0?
Because if you plug 3 halves in here, 2 times 3
Oh.
halves, okay, minus 3, it's the same thing. It's what you saw here. This is how you get rid of it. Make that a parentheses. So that's what you're going to have to do when you have a square root in the denominator. Okay? So when you have a square in the denominator, that's what you're going to have to do. You're going to have to eliminate that value. Okay, I think we've got. State the domain. Real quick. Yep, okay, good. This is our last one. Okay? Last one, and then I'll give you your assignment. So, state the domain. X squared minus 16. So what's the first thing you're going to do? Set it equal to 0. Very good. Okay. Add 16, you get. And so what do you get? Plus or minus 4. Okay. So now we need to figure out, we've got 2 values. We've got negative 4 and positive 4. And if you remember with square roots, we did intervals. So now I've got to figure out what interval works here. So I've got to plug in values. What's the number smaller than negative 4? Smaller than negative 4? Negative 5. Does negative 5, if I plug negative 5 in and square it, what do you get? 25 minus 16, does that work? Yeah, so numbers smaller than negative 4 will work. So I'm going to put a negative infinity there. What type of bracket do I use with negative infinity? Parentheses. Do I include negative 4 in a square root? Yep. Okay. All right, here's the number 4. What would be a value around number 4? What? 0? Okay, so let's plug in 0. If I plug in 0, what do you get? Negative 16, it's bad. So can I go less than 4? So which way am I going to go? Bigger. Yep, so what am I going to put now? What? Infinity, yep. Am I going to include 4? Yep, bracket, and then parentheses. Okay. All right, lots of information. Okay, this is what you need to do. 2 through 36, the evens, 39 through 44. Okay, 2 through 36, the evens, 39 through 44.